Hey everybody, let's wrap up our Unit 1 together. We're talking about polynomial functions, and we're going to be re-reviewing end behavior. Okay, so we're taking a deeper dive of what it means to have end behavior and how to describe it mathematically. So here we go. Again, we're looking at end behavior. So the most extreme left side and the most extreme right side of a polynomial will either go up or down. We've seen this before, so let's talk about how do we describe this mathematically. So on the left side of a polynomial function, let's draw a polynomial function. Okay, let's just say it looks like this, okay? The left side here will be this farthest left point, and we can see that as it goes down, it's also going to the left, or as it's going left, it's also going down, and it's continually going down until it reaches negative infinity. And we can see here on the right side, it's continually going up until all the way to the right, it reaches positive infinity. So the limit that we're talking about are those y values, and we use this mathematical notation that looks like this. So to describe the left side, we say the limit as x approaches negative infinity. You'll see this a lot in calculus, but this x minus infinity has to go right under that limit notation, where we say p of x, the limit as x approaches negative infinity, aka the left of the function. And here we can see it's going, if it's on the left side, we would describe whatever that is. Okay, so we'll describe where that is or what value it's going to. And then on the right side here, we say the limit as x approaches positive infinity, right? Because as we're looking on the right side of the function, x is increasing. We can see the function will be up here. As we see it's going to the left, we see x is approaching negative infinity, and it'll be going down. But the way that we describe that is we say, hey, the limit as x approaches infinity of p of x is, and then we'll put whatever the value is. Okay, so that's how that generic notation will go. So as the x values approach negative infinity or positive infinity, so negative infinity looks like this, positive infinity looks like this, do the y values get larger or smaller? Meaning, does the left side go up or down? The following chart is how we describe the end behavior with that specific notation. So if on the left side, if we're going to the left and up, this is going to look like the limit as x approaches negative infinity. This means left in math. P of x, if it's going upwards, is going to positive infinity. If the left side is going down like this, we say the limit as x approaches negative infinity, aka left, then the function p of x is going down to negative infinity. Okay. On the right side, if we see that it's going to the right and up, we say, okay, that's the limit as x approaches infinity. That's how we say right in math function notation. P of x is also going to be going up to positive infinity. And if we go to the right and down, we say the limit as x approaches infinity, P of x is going to negative infinity. Okay. So let's talk about what this is in context of an actual function. So here's f of x. We can see that it's going to the left down, right? If I look at this, as x is approaching to negative infinity, f of x is going downwards. Same thing here, as x approaches positive infinity, the y function goes downwards also. So let's go ahead and describe that behavior using function notation. So on the left side here, how do we say left in math notation? We say the limit as x approaches negative infinity is how we say left. The function is going where? We can see it's going down to negative infinity. So we say negative infinity, which means down. Okay. How would we describe the right side of things? So on this side here, we can see as we go to the right, which is the limit as x approaches infinity, that's how we say the right. We say p of x is going where? It's going down, and so we'll say negative infinity again. Okay. So number two, let's see what this would look like if I went from the words to a drawing. So the limit as x equals negative infinity. This is like saying the left. So as we're going left, P of x is going to infinity. This means up. So as we go to the left, so as x is going to the left, it's going to go upwards. So we can kind of sketch that however you want, just, maybe something like this. And here, as the limit as x approaches infinity, this means as it's moving to the right, P of x is going to negative infinity, which also means down. So as we're going to the right, f of x is going to be moving downward. So we're going to see something, maybe it looks like this. And then we can connect those two in the middle to make sure it looks like a function that uses both of those limits to the left and to the right. Okay, you don't need a graph to describe the end behaviors of the function. You only need to recognize it, and we've talked about it before, but the leading term, right? So if I don't know what the graph looks like, I can know what it will look like based off its polynomial. And the leading term, remember, is the largest exponent, aka the degree. Okay, so depending on what this does, going left or right, this is the only one that matters. So if the leading term has an even degree, the left and right side will go the same way. We've talked about this before, but we're going to do it in terms of this notation. So remember, as we do the left side here, the limit as x approaches negative infinity, that's the left side. If it's even and positive, remember that it looks like it's going to the left and up. So we say P of x or f of x would look like it's going up to positive infinity if it's going upwards. And on the right side, if it was even and positive, this would look like it's going up and to the right because they're going to match the same direction. So we're going to say the limit as x approaches positive infinity, P of x is also going upwards to positive infinity. So if I was talking about even and negative, okay, something like this, remember even and negative means we're going to go to the right, down, and we're even, so we're going to match it. So we say the limit as x approaches negative infinity, aka left, P of x is going to negative infinity. And on the right side, the limit as x approaches positive infinity, P of x is going down to negative infinity. If the leading term has an odd degree, though, the left and right side will behave oppositely, or as opposites. Okay, remember the right side is dictated by whether it's positive or negative. So if it's odd and positive, the right side is going to go, the right side is going to go up. And because it's opposite, the left side will go down. So here we go. The limit as x approaches negative infinity, P of x will go to negative infinity. And on the right side, as the limit approaches, as x approaches infinity, P of x will go up to positive infinity. If it's odd and negative, remember negative means the right side goes down, and odd means that it's opposite. We say that the limit as x approaches negative infinity to the left, P of x will go up to positive infinity. And the limit on the right side, so x approaches positive infinity, P of x is going to be going downwards to negative infinity. Okay, so it's going to be super important that you get that mathematical notation down. Let's go ahead and practice some of this, okay? So describe the end behavior of each polynomial using that limit notation. So again, we're looking at our leading term, which is negative and odd. So remember what that looks like. Kind of just to remind you, negative means it ends downwards to the right, and odd means it starts opposite. So we're going to say this on the left side. Remember how we say left? We say the limit as x approaches negative infinity. And then P of x is doing what? Well, it's going upwards. So we say positive infinity. And on the right side here, we say the limit as x approaches positive infinity, P of x is going downwards to negative infinity. All right, push pause right here. And I want you to try number 4 and number 5 on your own. All right, hopefully you tried it. Remember, we're going to look for that leading term first. This tells me that it's positive and odd, which means we're going up to the right, and opposite is down to the left. So we say the limit as x approaches negative infinity, P of x is going downwards, and the limit as x approaches positive infinity, P of x is going upwards. On the last one here, you look at your leading term. This is negative even, which means we're going down to the right and matching it on the other side. So we know the limit as x approaches negative infinity to the left, P of x is going negative infinity. And the limit as x approaches positive infinity to the right, P of x is going also down to negative infinity. Great job. See you back in class.